So I'm gonna.
that in your calculator. I saw log.
No. No.
What? Why not?
So I'm gonna rewrite this row using powers of 2. So log base 2 of 2 to the what? How do I write 2? How do I write 2 as a power of 2?
The 1.
To the 1 is, what was it equal to?
1.
And then this one was, Amelia, what is log base, how do I rewrite this as a power of 2?
Log 2.
Log base 2 of 2 to the 2?
What does log base 2 mean? Why is it base 2?
This is the base.
Yeah, but how do you do that on your calculator?
You don't.
Why not?
What did that equal?
The 4.
Yeah.
No.
No,
2. How do I write this one as a power of 2?
So me?
Whoever. Charlotte.
Yeah.
Oh, goodness. I have no idea.
What's 8 as a power of 2?
4 to the, 2 to 3?
2 to the 3, and what did it equal?
8?
What did this equal?
3?
Yes. Kira, how do I write log 128 as a power of 2?
Log 2, 7.
2 to the 7, and what did it equal?
7.
7, what's the pattern?
The bases cancel. And you just leave left with whatever x from it is. It's like n, a equals to n. Log bb n space n.
Okay, this is like saying x times 3 divided by 3 equals x. It's like saying x plus 5 minus 5 equals x. It's like saying square root of x squared equals x. So Warren, back to your point, this is b to the n, and it's log base b of that. So this is like multiplicative inverse. This is additive inverse. This is power inverse. This is exponential inverse. Log is the exponential inverse of is the inverse of exponentiation. So what is so this pattern right here, this one right here. We can get a pattern from that as well. So if I say log base 2 of 2, what was it?
1.
If I imagine I said log base 3 of 3, what would it be?
1.
Log base b of b, what would it be?
B.
1. All right, so you're ready for the definition of logarithm.
I'm ready.
Wait, but how do you know what your base is gonna be?
What you're like if you're undoing an exponentiation.
Like when you were log base 3 versus log base 2. How do you know what base
Looking ahead, I might have 7 to x equals some number. Let's just say 22 for no reason. And if I want to solve for x, I want to take the log base 7 of both sides. And that leaves what on the left side?
1 to the x.
No.
X.
Yeah, x. This cancels.
Yeah.
And then I just put it in my calculator, log base 7 of 22.
Wait, but no, that's what I'm saying. How do you put it in?
You don't. Yeah. We're not there. Definition of log.
Can I ask the question anymore?
Oh my goodness, why are you so feisty? Definition of log. So if
Wait, what does it say after logarithm?
logarithm.
All right.
Definition of logarithm. if b to the x equals a, then x equals, can anybody guess?
Log B A.
Log base b of a. So here's our b, here's our a, and here's our x.
Oh hey, you know what's crazy?
What?
When we were doing like our CAX, and we're talking about like constant, like C, and then the base A, it's like the same. Like your base B is gonna be log base B. Does that make sense? And then it's like A. It's just stays what it is.
So this kind of stands alone as the definition of log. This is the definition of a logarithm, and we can use this to derive some properties of logs. So if we have b to the x equals a, and b to the y, so same base, different exponent, different answer, equals c, then the equivalent log forms are Warren.
Yeah.
So I have some b to x equals a, and I have b to the y equals c. What are the equivalent log forms of those?
For that one, it's log b of c.
C,
Is that
C
it?
is over here.
The first one is log b of a. Yeah, but the first one is log b.
So I have an equation here. I'd like to end up with an equation as well.
Yeah, I'm confused.
So I have two sides of an equation, and I'm rewriting it. It's still equal over here using the definition of log. Lets me get from this expression to this and back and forth. So if I have this written as an expression with an exponent, how can I rewrite that as an equivalent expression with a logarithm?
Oh, okay, so x equals to log b of a.
Log x equals log b of a. That's literally the definition.
And y equals to log b of c, yeah.
Log sub b of c. Right.
Hey.
So I'm gonna multiply these together. And Carla, what do I get?
When you do the x log b of a,
No, this line. I'm gonna multiply these together.
b, like you like in parentheses.
No, I'm just gonna multiply. I'd like to say AC equals what?
ac equals bx plus by. bx times by.
Bx times by, and then using the properties of exponents, how can I combine that?
Bxy.
Just XY.
b to the power of xy.
So if I have 2 cubed times 2 to the 5th that means
2 to the 8th. B plus x plus b to the x plus y.
it's what is it? What is it?
X plus y.
The exponent is x plus y?
Yeah.
Yes. Right? So far so good? So I'm going to rewrite that. Now I'd like to take the log base b of both sides. What do I get? Eric?
Take log of both sides.
Yep.
What both sides?
Both sides of the equation.
AC is equal to.
Now I'm going to take the log of it. Any help, Charlotte?
So weird.
I'm going to take the log.
Log of what?
So when you're doing a step in math, you might have something here, and that equals something here, and you might decide to square both sides. The first step is you just square both sides, and then the next step you can figure out what the implications are.
Can I try?
No, Kira had her hand up.
X plus y equals log base b ac.
No. What do you say, Warren?
X plus y.
No, I have something here, and I have something here.
Do you want to? Okay.
And I want to take the log base b
Okay, log
of both sides.
log base b ac
Yep.
equals x plus y.
Equals log base b
X plus y.
b x plus y.
Which can't the b's just
They cancel, and so by the definition of log, what am I left with?
log base b ac equals x plus y.
And then substituting in, remember that x equals what? What did x equal? Eric, what did x equal?
X equal log b of a.
And what did y equal?
Log b of c.
Log b of c. So we're writing this in strictly log terms. I have log b of a times c equals
Equals log b of a.
log b of a plus log b of c.
Huh.
This is a property of logarithms, and it comes because when you multiplied your exponents together, that multiplication got converted to addition. This happens in the log world as well. So I'm sorry if this looks like an exponent. This is log b of ac equals log b of a plus log b of c. This multiplication here gets converted to this addition. That is a property of logs. We did it. Woo! Yay! The crowd goes wild.
The crowd is going wild.
The crowd is going super disappointed.
Yeah.
Is everyone okay?
I'm free!
You guys need somebody to come and escort you to your next thing?
I'm free!
You feeling bad? You feeling like your brain's warped?
Wait, what is. Hey, can I look up what is AC? I forgot.
I just don't wanna do that.
You're lying. You understand it.
So I had some exponent equals some answer A, and I had some another exponent equals answer B, but they had the same base. They had the same base. So I can rewrite this using the definition of log. I rewrote the first one as this, rewrote the second one as this. I multiplied them together because I wanted to get the benefit of the multiplication turning into addition here.
Oh, you
I took the log of both sides, and then I had the log of this equals the log of this, and then log b of b to the whatever. Those just cancel because those are inverses. That left me with this exponent down here, and then I could reach back up here and get what that meant, and write everything in terms of logs. And this gives me my first property of logs. Log, as long as you have the same base, log of two things multiplied together equals the log of the first thing plus the log of the second thing.
So like just to identify it. We're gonna that b of x multiple b of y equal to b of x.
Sorry, what?
Just to identify this for AC equal to b of x plus y. So you add log.
I took the log both sides.
Side and you find out that x. Thank you. Yeah.
Yay!
Are you good with that, Warren?
I'm free.
I think I get it.
Thank you.
So this is just to show you where this comes from. You'll need to know this property. So this property should go on your index card, but this is where it comes from. I just wanted to show you that
Well, I
it's.
feel like I could have like done some of those steps in my head though. Like I could have just gotten like straight from AC equals to BXY, like to like XY equals to log
Have a good day.
like XY equals to like log EAC.
Yeah, he's just right there.
Like I could have just like done that part in my head though.
But it's easy, to me, it's better to write it out. And did you get a chart?
Yeah.
Awesome.
Good chart.
I don't think so.
Let me know if you want to come back and redo that.
I feel like
I'm not.
it becomes like kind of
I'm not here later today.
Okay.
Are you going to sports right now?
Yeah, I am.
Okay.
Okay, catch you later.
See you later. Have a good day.
it becomes like kind of more complicated like written out. But like I could probably just like do that in my head, I think.
Once you get more familiar with it, it's easier to just kind of know how things work. It's just like the step where you had b to the x times b to the y. If you saw it in a concrete way, it's really easy to remember. I was about to write 2, 2, 2, like multiply together, 2 times 2 times 2 times 2 times 5, 2 times 2 times 2 times 2 times 2, and then show that makes this grouping of 3 and this times this grouping of 5 makes a grouping of 8. So although you guys snap to it faster than that, so I didn't get to that part, but that's sort of a reminder of why the b to the x times b to the y equals b to the x plus y.